Homework 13, measures of average, video 5, mid-range. Now, mid-range might be a measure of average that's new to you, but I assure you it is easy to calculate. Let's say we have a ranked quantitative data set. So it means we have numbers and they're in order. So first number, second number, all the way to the nth number, whatever it is. But they are in order. Then the mid-range is the first plus the last divided by 2. In other words, it's the mean of the least and greatest values. And I should go on record as saying that it is not necessary that the data set be ranked, be put in order. The only reason I said that is so that I can explicitly refer to the least value and the greatest value generically. But really it's just the average of the highest and lowest values. So having them ranked is not really that important. What's important is identifying the least and greatest values. Let's take a look at 3 examples. And if you've watched the previous videos, you probably know I'm going to say something about outliers. Hey, look, it's the same data sets we had before. Let's consider the data set 5, 9, 10, 11, and 17. To calculate the mid-range, we simply have to take the mean, average, of the lowest number, which is 5, and the highest number, which is 17. 5 plus 17 is 22, and 22 divided by 2 is 11. The mid-range is quick and easy to calculate. So if you don't know all the values, but you know the extremes, you can kind of come up with a rough number to represent the mid-range. And as before, I took the previous data set and threw on an outlier of 5,000. Do you think the outlier is going to affect the mid-range? Yeah, because the calculation of the mid-range explicitly requires using the least and greatest values. So if we throw on an outlier, we either threw on an extremely large value or an extremely small value. So yeah, the mid-range is going to be heavily influenced by outliers. In this case, the mid-range would be 5 plus 5,000 divided by 2. That's 5,005 divided by 2, which will be 2,502.5. I honestly don't know why I am inconsistent with how I make my 2s. Flat bottom, loopy bottom. I personally think it's a battle between my left brain and my right brain, but that has yet to be confirmed. So without me writing it, it's pretty clear that the mid-range is heavily influenced by outliers. So what's up with this third example? Well, take a look at this third data set compared to the second data set. And notice that they have the same least and greatest values, which means that they're going to have the same mid-range. It's still going to be 2,502.5. But here's the biggest flaw with mid-range. Mid-range really doesn't capture where the numbers are in a data set. For example, in the second data set, if I were to put these on a number line, most of them would be way on the left and 5,000 would be way off to the right. But if I were to put this data set's numbers on a number line, only 5 would be on the left and all of these large numbers would be way down on the right. But even though the spread or the distribution of these values on a number line are completely different, they have the same mid-range. So one of the major flaws with mid-range is it's completely oblivious to the numbers in the middle. That and the fact that it's heavily influenced by outliers is one of the reasons it's not a common measure of average, but it's listed because it's an easy one to calculate.